Hi and welcome to chemistry. Today we'll be covering significant figures. So this section is going to include what is the purpose of significant figures, the rules for addition, subtraction, multiplication, and division using significant figures. We're also going to be looking at dimensional analysis using significant figures, and lastly, precision versus accuracy. So what is the purpose of using significant figures? Well, the whole purpose of using significant figures is so that your final value is not more precise than your beginning value. Now, some of the benefits of this are going to include you'll never have to ask where to round again. You'll also be able to prevent rounding errors that can be fatal. So remember, all equipment in science do not have the same precision. In fact, the ones that cost more are going to be the ones that are more precise. So let's go ahead and look at some questions now. The first one reads, which of the following values is more precise? 7.5120 versus 7.52. And the answer should be 7.5120 because there's more numbers attached to it, meaning it's more precise. Now question 2 reads, which of the following would be a correct value using a scale to a precision of plus 0.01 grams? Now this is just trying to tell you that you can only have 2 decimal spots available past the decimal. So if you look over here, we're going to find the one that has 2 decimal places, and in this case, it's 7.52. So question 3 says, justify why it would not make sense to have a 7.5210 grams as a final answer if your scale was only 0.01 grams. And we kind of talked about that, and if you think about it, it just wouldn't make any sense. How could your final answer be more precise than what your scale can actually measure? Let's go ahead and take a look now at exact numbers versus inexact numbers. Explain the difference between an exact number and an inexact number. One exact number is just going to be a counting number, so something like 1, 2, 3, 4, 5, 6, 7. It's also going to be a conversion factors within the same system. So in this case, you're able to have infinite number of sig figs, and it's just going to mean the same thing. So an example of that is, say that you have 50 people in a room versus 50.0 people versus 50.000 people. It really doesn't matter. Your answer for the number of people in a room is always going to stay as fixed. Now, in an inexact number, we're looking at something that you measure. It's also going to be a conversion factor between 2 different systems. So remember, in this case, decimal points do matter. So question B reads, for each case, indicate whether the result is an exact or inexact number. The number of faces, well, because we can count the number of faces, that's just going to be an exact number. The mass of 6 apples, because we are weighing this is going to be an inexact number. The number of seeds in an apple, well, once again, we're able to count this, so this would be an exact number. The number of feet in 1 mile, well, feet and mile are both within the same system, so this is going to be an exact number. The last one reads, the number of liters in 5 quarts. Well, liters is going to be in your metric system, and quarts is going to be in your imperial system, so in this case, we're going to have an inexact number. Let's go ahead and look at some of the rules for counting significant figures. The rules are all non-zeros will always be significant. So in this case, any number than a 0 will always count as a significant number. So 2 significant figures here, 3 significant figures here, and 4 significant figures here. The next rule says that sandwich zeros are significant. So in this case, when a 0 is between 2 real numbers, then that 0 would also be significant. So in this case, we got 3 significant figures, and in this case, there's 2 zeros between 2 real numbers, so these 2 zeros will count as significant. So we got a total of 4 here. Now, rule 3 says leading zeros are never significant. Now, the word leading means that you're leading up to a real number. So in this case, because these zeros are leading up to a real number, they do not count. And so we only have 1 significant figure here, and in this case, we have 2. Here, these 2 zeros do not count because they're leading zeros, but this is a sandwich zero, so we have a total of 3 here. Now, rule 4 says that trailing zeros are significant if a decimal point is present. So notice that over here we have a decimal point. So in this case, because they're not leading zeros and there's a decimal point present, these will all be significant. So we got a total of 1, 2, 3, 4, 5 significant figures here. And over here, these are 2 leading zeros, so they don't count. Now we got that decimal point present. This 0 counts because he's a sandwich 0, and this 0 is going to count because he's a trailing 0. So in this case, we got a total of 4 significant figures. So rule 5 says that exact numbers have as many significant figures as needed. So whenever you're counting something, 1, 2, 3, 4, 5, those won't count towards your total number of sig figs. Now rule 6 says that conversion factors do not count towards the number of sig figs. Now remember, this is when you're converting within a system. Now rule 7 says ignore the base power 10 and exponent when in scientific notation. So in this case, whenever you get a scientific notation problem, you're just going to ignore the times 10 to the third, and you're just going to focus on the numbers in the front. So in this case, we only have 4 significant numbers here. So let's go ahead and take a look at some practice problems. 3.82, well, this has a total of 3 significant figure problems over here. 24 has a total of 2 significant figures. This next one is 0.0619. These are leading zeros, so they do not count, so we got a total of 3. Now over here, we got times 10 to the 4th. Well, we don't look at this, so we got a total of 2 significant figures. Here we have a trailing 0, so we got 5. Lastly, we have 712,000. Now notice there's no decimal point present, so we only got a total of 3 significant figures there. So I want you to go ahead and pause this video and try these by yourself now. Now in the first one, you notice that there's no decimal point, so this should have 1 significant number. The next one also doesn't have a decimal point, so 1 significant number. So on the third one, we can see that there's a decimal point present. And because there's a decimal point present, these 2 zeros will count. So we got 3 there. Over here, there's also decimal point, so there's 3. Here, there's a decimal point present, so there'll be 4. Here, there's no decimal point present, but there's 2 sandwich zeros, so they count. That's 4. And this one will not count, so you should have a total of 4. Here, we have a decimal point present. So because there's a decimal point present, and these are all trailing zeros, and these are sandwich zeros, they will all count. So you get a total of 7. So over here you have a decimal point present, and all of these are trailing zeros. This one's also a sandwich zero, so all of these will count. So you have a total of 6 here. So on the next one we have a decimal point present. Now these are leading up to a real number, so they do not count. Now these are trailing a real number when there's a decimal point, so they will count. So you should have a total of 4 in this one. Here you have 1, and over here they all count except the first one, so we should have a total of 3, 6, 7. So let's go ahead and take a look at certainty versus uncertainty sig figs. So when measuring something, always add one uncertainty digit, aka read what you can, but add only one extra digit, which will make that one significant as well. So question A reads, what measuring device is using the picture to the right? You should know that this is a graduated cylinder. Question B says, how should you record the volume of the liquid? What you want to do is you want to measure out the liquid from what you can see. In this case, we're going to say that it's 43. Now we know for sure that it's 43, but we got to add that one extra digit. That one extra digit is going to represent our uncertain digit. In this case, I'm going to say that it's 0.0. So we should have a total of 3 sig figs. What values in centimeters would you record for measurements A, B, and C? Now when you look at A, we're going to say that this is 0.7. We know that it's 0.7 because this is 0.5, so this makes it 0.7. But this can be 0.70, 0.71, 0.72. In this case, I gotta throw in that one extra digit, so I'm gonna say that it's 0.70. Now for B, I know for sure it's 1.5, but it can be 1.51, 1.52, or 1.53. In this case, I'm going to say that it's 1.52. Now on C, it looks like it's around 2.8. I know for sure that it's the 2.8, but I gotta throw in that one extra digit, so I'm gonna say 2.88 in this case. Now it's okay if you have 0.9 or 0.7. That's the whole point of using that one extra uncertainty digit. So how many sig figs do each of the following have? Well, for A we have 2 sig figs, for B we have 3 sig figs, and for C we also have 3 sig figs. Let's go ahead and look at the rules for multiplication and division versus addition and subtraction. Now the rules for addition and subtraction state, you want to round to the least number of decimal places. Now if there is no decimal point, then round to the closest whole number. Now lastly, it might be beneficial if you just draw a line downward to help guide you. Now, one extra thing that I want to add for both of these rules is if the number on the right is greater than 5, you need to round up. If it's less than 5, you keep it the way it is. So this is what I mean. First, focusing on addition and subtraction. Over here, you're going to notice that we have 211.726 plus 720.65. Now notice, we only have 2 decimal places here, and here we have 3. In this case, I'm going to choose a smaller number, which is 2. So my final answer can only have 2 decimal spots past this decimal point. In this case, I'm going to stop the 7. Now I need to look to the right to see whether I round this number up or if I keep the same. In this case, he's greater than 5, so I'll round him up. So my final answer is going to be 932.38. This next one says that you have 351 plus 471.32. In this case, he has no decimal places past the decimal, so our final answer should just end at 822. I'm going to stop on this 2. Look to the right, he's less than 5, so my final answer would be 822. Next, we have 350.04 plus 720. Now notice there is no decimal point at all, so in this case, we want to round to the closest whole number. So we're going to stop at 1070. We'll then look to the number to the right. Now, because he's less than 5, he's just going to stay as 1070. Next, we have 500 plus 1.365. Now, once again, you're going to see that there's no decimal point present. Now, because there's no decimal point present, we want to round to the closest whole number. So when you come down over here, you're going to get 501.365. Now, you're going to stop at the 1, and then you're going to look to the right. Is he greater than 5? And if he's not, you're just going to keep it as 501. So that pretty much sums up the rules for addition and subtraction. So let's focus our attention now to the multiplication and division. So for multiplication and division, you just want to round to the least number of significant figures. Now you want to fill in zeros as necessary to make sense of your answer. And so what I mean by that is, when you look at 13.1 times 1.2039, he has 3 sig figs, while he has 5 sig figs. So our final answer is going to just be rounded to 3 sig figs. So we're going to take 157, we're going to look to the right, he's greater than 5, so our final answer would be 15.8. Now next we have 1576 times 12.4. He's got 3 sig figs, he's got 4 sig figs, so our final answer must contain only 3 sig figs. So when you look at this number over here, we got 19,542.4. So we care about 1, 2, 3. So I'm going to look to the right. Now because he's less than 5, he's going to stay as 195. But think about it, 1,576 times 12.4 does not just equal 195. So now you have to fill in those extra zeros, and you're going to get 19500. Notice you don't put a decimal point and you don't include the other numbers because you only need 3 significant numbers here. Alright, let's go ahead and take a look at addition and subtraction now. Here's some more practice problems. I want you to change the values of the answers that are given to the correct number of sig figs. In this case, we got 3 decimal places past the decimal, and here we have 2. Because this is addition and subtraction, I want the least number of places, so it's 2. I'm going to stop at this 4. I'm going to look to the number on the right. My final answer is simply going to be 7.74. Next, we got 420 plus 3.51. Now notice, there is no decimal places after this, so we want to round to the closest whole number. So we're going to stop right here at 423. We're going to look to the right. He's greater or equal to 5. So because these 5 are greater, we're going to go ahead and change him to 4. So our final answer will contain 424. Next, we got 45,300 minus 176.21. Now, in this case, there is no decimal point present at all, so we run around to the closest whole number. So we're going to end our answer right here at 45,123. But we're going to stop at the 3, and we're going to see if this number is going to round it up or not. In this case, it does. So our final answer is going to be 45124. Next, we have 45,300 plus 176.21. Now notice, there is no decimal point present again, so we're going to round our answer to the closest whole number. So at this point, it's going to be 45,476. We're going to stop here and look to the right. In this case, he's less than 5, so our final answer would simply stay as 45,476. Now, I included a significant figure calculator here, and the reason why I included it is because when you first start off practicing the problems, it might be beneficial to check your work by using it. Alright, so in this case, let's go ahead and see if I get the same value. I'm going to go ahead and paste that last problem from the previous slide, and you're going to see that when you add the 2 up, your final answer is going to be 45,476. Let's go ahead and compare that to our other answer. In this case, you're going to see that they're the same. So let's go ahead and look at some addition and subtraction problems. Try these by yourself. I want you to perform the following calculations and put the final answer in the correct number of sig figs. So on this first one, you got 0.14, so we got 2 decimal places past the decimal. This one has 1 decimal place past the decimal. This one has 4, and this one has 2. In this case, because we're following the addition and subtraction rule, we're looking at the fewest number of spots past the decimal. In this case, it's 1, so our final answer should just have 1 decimal spot. So we're going to look to the right to see whether it's greater than 5 or less than 5. It is less than 5, so our final answer is going to be 10,206.5. On this next one over here, we got 148.77 minus 106.409. In this case, we care about 2 decimal places past the decimal, so we're going to stop at the 6. Now, because the 1 is less than 5, our final answer is going to remain as 42.36. So when looking at multiplication and division problems, I first want you to label the smallest number of sig figs and then change the value to the correct number of sig figs as your final answer. So in this case, he has 4 significant figures. He also has 4. He has 3 because leading zeros never count. And then here we have 5, and then we have 5 as well. So in this case, our final answer should only contain 3 sig figs. Now these 2 zeros do not count because they're leading, so we're going to stop at the 9. We're then going to look to the right, and he's greater than 5, so that changes him to a 0, which rounds him up to a 7. So for this answer here, we're going to have 0.0170 as our answer. So let's go ahead and look at this problem over here now. Over here you have 2,342 times 11.3. He has 3 sig figs while he has 4. So our final answer should just contain 3 sig figs. So we're going to stop at this 4. Now, once you stop at the 4, you need to look to the right. He's greater than 5, so he rounds him up to a 5. So we get 265. But think about it, 11.3 times 2,342 is not 265. So now we need to fill in those extra zeros, and we get 26500 as our answer. Now for these type of problems, you really just need to use common sense. Some of you guys might have kept that as 265, but always ask yourselves, does that make sense? And if it doesn't, fill them in with zeros. Now don't include the decimal point. If you include those decimal points, then these will become significant, and then the answer will be wrong. Next, we got 8.4 times 5. In this case, we have 1 sig fig times 2. Our final answer should only contain 1 sig fig. This next problem is 32.6 divided by 2.8. He's got 2 sig figs while he has 3 sig figs. So we're going to stop over here on the second significant number here. We're going to look to the right. He's greater than 5, so then our answer is just going to become 12. Next, we have multi-step problems. When doing multi-step calculations, do each step to the correct number of sig figs as you go, unless it's all the same one procedure. So what I mean by that is, when you look over here, you got 3.6 times 4.639. Now, what we're going to do is we're going to first multiply these out. So when you multiply them out, you get 16.7004. But notice, our final answer should only contain 2 sig figs within this multiplication part. So then we're going to change this number to just 17, because we're going to stop at the 6, look to the right, he's greater than 5, so that makes him a 7. So now we got 17 plus 5.831. So he has no decimal spots, while he has 3. In this case, we want to round to the closest whole number. So 17 plus 5.831 gives you 22.831. We're going to stop here at the 22. We're going to look to the right. He's greater than 5, so our final answer would just be 23. Next, we have 9.24 minus 1.342. He's got 3 decimal places past the decimal, while he has 2. So when you look over here, we want to stop right here, 2 decimal places past the decimal. We're going to look to the right and notice that he's greater than 5. Because he's greater than 5, that changes him to a 0, which changes him to a 9. So then we get 7.90. We're then going to take that 7.90 divided by the 2.3. Now he's got 2 sig figs and he's got 3 sig figs. So in this case, our final answer must only have two significant numbers. In this case, we get 3.434. We're going to stop on the 4. We're going to look to the right. And because he's less than 5, our final answer would just be 3.4. All right, so I want you to try this multi-step problem by yourself. Here you have 8.9 times 3.564 plus 2.316. So when doing the first part of this calculation, you get 31.7196. But because the smallest number of sig figs here is going to be 2, our final answer will also only just contain 2. So we're going to stop at the 1. We're going to look to the right. He's greater than 5, so this is going to change to 32. We then have 32 plus 2.316. So in this case, this gives us a total value of 34.316. In this case, we want to round to the closest whole number because he doesn't have a decimal at all. So our final answer would just be 34. Now let's go ahead and take a look at using sig figs in scientific notation. Now this is going to be exactly the same before, but now I want you to ignore the base power 10 and exponent when counting the total number of sig figs. So here we have 3.61 times 10 to the third plus 5.1 times 10 to the third. In this case, you're going to ignore times 10 to the third on both of these problems and focus your attention here. Because this is an addition problem, he's got one decimal place past the decimal while he has 2. Our final answer must only contain one decimal spot past the decimal. In this case, this gives us a value of 8.71 times 10 to the third. We're going to stop on the 7, look to the right. Because 1 is less than 5, our final answer will simply be 8.7 times 10 to the third. Next, we have metric prefixes. It's going to be to your benefit if you memorize these. You're going to see this a lot in chemistry. You'll also be seeing this a lot in physics. So start learning them today. Now, here's a great mnemonic that I use to help my students memorize them. It's the great mighty King Henry died drinking chocolate milk Monday night, and then a little smiley face at the end. And I have that written down for you guys on the bottom. And once again, that's the great mighty King Henry died drinking chocolate milk Monday night. Next, let's go ahead and practice using dimensional analysis to get the correct number of sig figs. Here we have a pencil that is 7 inches long. What is the length in centimeters? Remember, 1 inch is equal to 2.54 centimeters. Because this is a conversion factor, this will not count towards the total number of sig figs. Now here we have 3 sig figs, so our final answer should also contain 3 significant figures. So I want to start off with what they gave us. They gave us 7 inches as our starting point. Now to get rid of inches, we know that inches must go on the bottom. So inches will then get rid of inches, and then we're stuck in centimeters. Now once you get to your final answer, you want to go ahead and check your rounding. Here we need 3 sig figs, so we got 1, 2, 3. I want to look one number to the right, and because he's greater than 5, that's going to change him to 17.8. So question 2 reads, the speed limit on many highways in the US is 55 miles per hour. What would the number be in kilometers per hour? We want to start off with 55 miles over 1 hour. Now to get rid of miles, we have the conversion here. 1 mile is equal to 1.6 kilometers. So at this point, miles will get rid of miles, and we're stuck with kilometers per hour. Now, because they're asking for kilometers per hour, we're done. But we need to look at our significant numbers now. Here we have 2 significant figures. So we're going to stop at the 88. In this case, that is just our answer. Alright, so here's an expert level question for you. A Japanese car is advertised as having a gas mileage of 15 kilometers per liter. I want you to convert this rating to miles per gallon. So in this case, our starting point is going to be 15 kilometers over 1 liter. So to get rid of kilometers, I'm going to go ahead and use this conversion over here. So on the bottom, I'm going to have 1.6 kilometers is equal to 1 mile. Now kilometers will get rid of kilometers, and we're stuck with miles per liter. But we don't want miles per liter. So what we want to do next is get rid of liters. So now I will use this conversion right here, and I'm going to put liters on top. So we know that 1 liter is equal to 1.06 quarts. So now liters will get rid of liters, and our current answer is in miles per quart. But I don't want the answers in mile per quart. So in this case, I want to get rid of quarts. So 4 quarts will go on top, and this is going to be over 1 gallon. In this case, the 2 quarts are going to cancel out, and our final answer is going to be in miles per gallon. So when you multiply and divide all of this out, you get 35 miles per gallon. Now, if we go back to our original answer, we only have 2 significant figures here, so our final answer should just contain 2. In this case, it does. So we're good at just 35. Next, let's look at a bit more challenging problem. It reads, the latest model Corvette has an engine with a displacement of 6.20 liters. What is it in cubic inches? Remember, 1 cc is equal to 1 milliliter. This is also equal to 1 centimeter cubed. So in this case, whenever you hear people at the hospital say, stat, go get me 7 cc's, what they're really trying to say is go get me 7 milliliters, or 7 centimeters cubed. So let's go ahead and solve this problem. And in order to solve this, we're going to start off with our starting point at 6.20 liters. Now, we want to first convert liters to milliliters using that metric system chart from before. So in this case, we know that 1 liter is equal to 1,000 milliliters. Liters will then get rid of liters. Our current answer is in milliliters. So then we want to go ahead and take our conversion from here, and we're going to convert from milliliters to centimeters. So we're going to write 1 milliliter is equal to 1 centimeters cubed. And milliliters will get rid of milliliters, and now our current answer is going to be in centimeters cubed. Now, in order to convert from centimeters to inches, we know that 1 centimeter is equal to 2.54 inches. But in this case, because it's cubed, we're just going to say that 54 centimeters cubed is equal to 1 inches cubed. So in this case, we're going to cube this 3, and we'll also cube this 3 here. So make sure that you include these numbers in your calculations. Our final answer, therefore, is going to be 378.34. But in this case, if you look back to your original problem, we only need 3 significant figures. So my final answer should be 378 inches cubed. Next, we have precision versus accuracy. Precision is how close you are to each other, while accuracy is how close you are to the actual target. So question B reads, which set of measurements are precise? Well, in this case, the ones that are precise are going to be the ones that are closest to each other. In this case, he's pretty precise, and he's also pretty precise. So we're going to say both B and C are precise. Next it says, which set of measurements are accurate? Accurate is how close you are to the intended target. In this case, the intended target will be the bullseye. So the only ones that are going to be on the bullseye looks like it's going to be C. Now, which set of measurements are both precise and accurate? Well, this is precise, but this is also accurate, so we know that the answer will also just be C. Next, I want to end off with the joke, because a lot of teachers are going to mark your answers wrong if you don't use the correct number of significant figures. And it reads, yes, your answer was precise, but it's marked wrong because you've... Next, I want to end off with the joke, because a lot of teachers will mark your answers wrong if you don't use the correct number of sig figs. And the joke reads, yes, your answer was precise, but it's marked wrong since you had to use sig figs. That concludes our lesson for today. Hopefully you guys feel more comfortable using significant figures.